to introduce you to the idea of concavity. Okay? But before we actually talk about that idea, I'm gonna remind you of something that you know from the past. Okay? Let f of x be a function and what we say is f of x is increasing if as x goes up, y goes up. So that's one fact. The second fact is f of x is decreasing if as x goes up, y goes down. And I'm mentioning these two facts because I don't want you to be confused or confuse the idea of concavity with the idea of when a function is increasing or decreasing. All right? So you'll see in a minute why I'm worried. So if you're doubting that these things make sense, just let's draw a little graph here for a second. Then here's an x and y axis. And try and imagine a function so that if x is increasing, y is increasing. Well, if x is increasing, that means we're moving in this direction along the x-axis. And if y is increasing, it means we're moving up vertically. So if we were to continue to do that, every time we moved right, we moved up, you'd end up with a function that might do something like this. Okay? But the general trend is that as that function moves right, it also moves up. And that's what it means for a function to be increasing. Okay. So in the same, sort of the same ideas, think about if we were going to imply what this is telling us. This is saying as x gets bigger, y gets smaller. So as we move to the right, y gets smaller. As we move to the right, y gets smaller. Maybe you get a function that looks something like that. But the general trend is that as we move right, we go down. So that's what it means for a function to be decreasing. Okay. So what does concavity mean? What's concavity talking about? Here's what we say. Okay. So we say f of x is concave up, which I'll denote most of the time as CCU, concave up, if as x goes up, slope goes up, which I denote usually with an M, or sometimes we say average rate of change. So we'll draw something that does this in a minute. And then we also say, that's the first fact. Number two, we say a function is concave down if as x goes up, slope goes down. Okay. So these are two definitions. So before we get a sense of what concave up graphs look like and concave down graphs what they look like, I just want to review slope with you for a minute. So here's an xy axis. If we think about it, someone would say, hey, well, what's the slope of the x-axis? Or a horizontal line. Any horizontal line has a slope of 0. We know that because if it's horizontal, the change in y in the numerator is 0. So that means a horizontal line has a slope 0. Perfect diagonal line in that direction has a slope of 1. In this direction, a perfect diagonal line at 45 degrees to the x-axis has a slope of -1. And now I just have to give some thought to the slopes that are in between here. So maybe we might ask what the slope of that line is. So maybe m equals 1/2. And then any slope up here, this has to be bigger than 1. So maybe we'll say 3. Okay? These are just estimates for the time being. That slope not quite -1, so it's between -1 and 0, so maybe something like -0.5. And then this slope, maybe -2. And just for fun, if you think of the slope of this line, we usually say the slope m does not exist. The vertical line has no slope. And you can kind of see that if you look at delta y over delta x. Think about delta y over delta x for a minute. If this fraction were undefined, that would mean that the bottom were equal to 0. Well, if delta x is 0, it means we're not changing x at all. And if you're not changing x at all, then you must be on a vertical line. So that's the reason why we say vertical lines have no slope, or the slope doesn't exist, because if you try and write delta y over delta x, you get something over 0. Okay. So let's see if we can draw a graph that's concave up. That's what we're going to try and do. So here we go. We know if it's concave up, the slope can't be the same all the time. And the reason we know that is because as x goes up, m goes up. That's the definition of something being concave up. So our slopes have to get bigger as x gets bigger. So I'm going to start by just picking a point here on the x-axis. I'm going to say, all right, I'm going to make the curve look, well, I want to draw this. I have to draw it in such a way that as I move to the right, it gets steeper, or the slope gets bigger. So something like this might do that. Okay? So let's give this a little thought. Let's verify that this does the job. Well, if we were to ask ourselves what we think that slope is here, near the origin, that line looks pretty horizontal. We might say m equals 0. But if we go over a little bit, we pick another point, we look at that slope there is a bigger number than this one is, a bigger positive number. So this is probably m equals maybe 1/2. And if we go even further, start to get steeper lines. So maybe that's m equals 1. So if you look at this graph, you say, all right, is it true that as x goes up, slope goes up? Yes, it is. Okay. Now, just for review, is this function increasing or decreasing? This function is increasing because as x goes up, y goes up. But maybe you can get the job done a little quicker by noticing all those slopes that we just drew, all those little green tangent lines, have positive slope. So delta y over delta x is positive. Well, if I'm saying y goes up over x goes up, that would definitely equal a positive number. So you could say a function is increasing when its slope is positive, even if the slopes aren't always the same, right? Okay, so this slope is 1/2 and that slope is 1. Now, sort of an interesting question is the function increasing at this point? And the answer to that is no, actually. What this function is doing is for like one instant in time, it seems to be just sort of remaining a horizontal line. And then once I get past it, it starts to get bigger and bigger slopes, and those slopes get bigger and bigger, meaning the thing's concave up. Okay, so here's an interesting challenge. Can you draw a function that's concave up and also decreasing? So take a minute to try that. I'm going to give you a hint. The hint is this. What's a bigger number? -1/2 or -1? That's my hint. So the first thing we do is discuss a popular wrong answer. A lot of times people think, okay, let's see. This is telling us that as x gets bigger, slope gets bigger. So some people think, okay, that means if slope's bigger, the curve must be steeper. That's what they think to themselves. And then this is decreasing. So this is saying as x gets bigger, y gets smaller. So here's a very popular wrong answer to this question. Okay? As x gets bigger, slope gets bigger, they interpret this to mean steeper. And then x gets bigger, y gets smaller. They think the graph has to do something like this. Right? Clearly, it satisfies the decreasing part. As x gets bigger, y gets smaller. Okay? Or we could say all these slopes, like that slope, and that slope, and that slope, are all negative. So it's decreasing. However, let's take a minute to estimate these slopes. We look at that slope, and we go back to this picture. A slope like the one we were just looking at might be maybe negative a half. And then this slope is steeper in the negative direction, so maybe this is negative 1. And then this slope might be, I don't know, negative 2 or 3, something like that. Okay. Now I ask again, is this thing concave up? And the answer is, so no is the answer. It is not the case that these slopes are getting bigger. They're actually getting smaller, and because when this number, negative 3, is smaller than these two numbers here. Okay? So this is actually a graph. Okay, this graph is decreasing and concave down. So that eliminates a possibility. And why is that? Because as x goes up, y goes down. That takes care of the decreasing part. As x goes up, the slope goes down. That takes care of the concave down part. All right, so let's see if we can get this graph drawn correctly. Well, here we are. We know we're probably going to start somewhere high up here on the y-axis because we're going to decrease as we go to the right. But the slopes have to get bigger. So maybe that'll do it. Let's make sure. First off, as x gets bigger, y gets smaller. That takes care of decreasing. So we can check that off. And now let's consider some of these slopes. So just look at these two slopes for a minute and ask yourself which one is bigger. The one on the right is. This slope might be negative 1, whereas this slope is probably negative 3. So this curve has the property that as x goes up, the slope goes up. So this curve is decreasing and concave up. The key thing here is do not confuse steepness with slopes being bigger, right? Because negative numbers sort of, they turn things around on us.